In this episode, we'll be discussing the cost, benefits, and challenges of nuclear energy. Nuclear power is one of the most controversial forms of energy production, with many questioning its affordability and sustainability. Today, we'll delve into the economics of nuclear energy, exploring its potential advantages and disadvantages, as well as the challenges that come with it.
Before me dropping value bombs of this video, I would like to introduce the Nuclear Power Engineering Principles course, now available on Udemy. This comprehensive course is your ticket to mastering the principles of nuclear power engineering and taking your career to new heights. Packed of engaging lectures, this course is designed to provide you with a deep understanding of nuclear power engineering principles. And the best part, upon completing the course, you will receive a prestigious certificate of completion to showcase your newly acquired skills and knowledge. It is a valuable credential that can open doors to exciting career opportunities in the nuclear power industry. Don't miss out on this incredible opportunity to unlock your potential with Nuclear Power Engineering Principles course. Enroll now and gain access to this top-rated course at an unbeatable price. But hurry, as this offer won't last long. Join us today and take the first step towards a successful career in nuclear power engineering. Enroll now in the Nuclear Power Engineering Principles course on Udemy and unlock your potential. Don't wait and start your learning journey now. Now, if you're interested, the link to this course is provided in the video description below.
Before we dive into the economics of nuclear energy, let's take a moment to review some background information. Nuclear power plants generate electricity by using nuclear reactions to heat water and produce steam, which drives a turbine to generate electricity. Nuclear energy currently accounts for around 10% of the world's electricity generation, and it's been lauded for its ability to generate electricity without greenhouse gas emissions. The topic of the economics of nuclear energy is a complex and multifaceted one that involves a variety of factors. Nuclear power has been a major source of electricity around the world for several decades, and has been praised for its ability to provide large amounts of baseload power with relatively low emissions. However, there are also concerns about the high capital costs of nuclear plants, the challenges of dealing with nuclear waste, and the potential for accidents or other safety issues. In recent years, the economics of nuclear energy have become increasingly important, as countries around the world grapple with the need to transition to low-carbon energy sources while also ensuring that electricity remains affordable and reliable. While nuclear energy has historically been viewed as a relatively expensive option, advances in technology and changes in the energy landscape have led some experts to reconsider its potential benefits. The economic benefits of nuclear energy are numerous and far-reaching. One major advantage of nuclear power is its cost-effectiveness compared to other forms of energy, especially when considering the long-term life cycle costs. While the initial capital cost of building a nuclear power plant is high, nuclear plants have a longer operational life and higher capacity factor than other forms of power generation, such as renewable sources like wind or solar. Nuclear energy is also highly reliable and can operate continuously for long periods of time without interruption, making it a stable source of baseload power. This means that nuclear power can provide a consistent and predictable source of electricity to meet the demands of industry and consumers alike. Additionally, nuclear energy has a very low cost of fuel, as the uranium used in nuclear reactors is relatively cheap and abundant compared to other fossil fuels. Another advantage of nuclear energy is its contribution to energy independence and security. Countries that have access to nuclear power can reduce their reliance on imported fossil fuels and avoid the volatility of the international oil market. This can also help to insulate economies from disruptions to energy supplies due to political or economic factors. Finally, the development and deployment of nuclear energy has significant potential for job creation and economic growth. The construction and operation of nuclear power plants require skilled workers, engineers, and scientists, and can contribute to the growth of local economies. In addition, the research and development of new nuclear technologies and fuels can spur innovation and technological advancements in related fields. However, it's important to note that nuclear energy also presents economic challenges. High upfront costs. Nuclear power plants require significant capital investments, making them more expensive to build than most other types of power plants. The cost of building new nuclear plants can be prohibitive, and this can lead to delays in construction or even cancellations. The construction of a nuclear power plant is a complex and time-consuming process, often taking 5 to 10 years or more to complete. This means that financing and project management must be carefully planned to ensure that costs and timelines are managed effectively. While nuclear power plants are efficient at generating electricity, they require significant operational costs for maintenance, staffing, and fuel. Nuclear power plants also produce radioactive waste, which must be stored and managed safely, adding to the operational costs. The risk of a nuclear accident, while low, can have significant economic consequences. The financial costs of a nuclear accident can be immense, with cleanup and compensation costs potentially running into the billions of dollars. With the rapid growth of renewable energy sources such as wind and solar, nuclear power is facing increased competition in many markets. Renewables are often cheaper to build and operate, and they are becoming increasingly cost-competitive with nuclear power. Nuclear power is heavily regulated, and changes in regulations or safety requirements can lead to delays and increased costs for nuclear power plants. Additionally, the regulatory environment for nuclear power can vary widely from country to country, adding to the complexity of international projects. Nuclear power has a negative public perception in many countries, making it difficult to secure public support and funding for new projects. This can make it challenging to attract private investors and financing for new nuclear power plants. Overall, nuclear power faces significant economic challenges, and its future as an energy source will depend on its ability to compete with other sources of energy while also managing costs and risks effectively. Now let's talk about the cost of nuclear energy. The cost of nuclear energy can be divided into two main categories: capital costs and operating costs. Capital costs refer to the upfront expenses associated with building a nuclear power plant, including the design, engineering, construction, and commissioning. These costs can be significant and are often a major factor in the decision to build a new nuclear power plant. The capital costs of nuclear power plants vary widely depending on the size, location, and technology used. In some cases, the cost overruns associated with building a nuclear power plant can be substantial. Operating costs refer to the ongoing expenses associated with running a nuclear power plant, including fuel, maintenance, and staffing. Nuclear power plants require significant amounts of water for cooling, which can be a costly expense in areas with limited water resources. In addition, the cost of storing and disposing of nuclear waste is also considered an operating cost. The cost of nuclear energy has been a topic of debate for many years, with proponents arguing that nuclear energy provides a cost-effective source of reliable, low-carbon electricity, while opponents argue that the cost of building and operating nuclear power plants is too high compared to other energy sources. In recent years, the cost of nuclear energy has become more competitive with other sources of energy due to improvements in technology and construction methods. However, the high upfront capital costs associated with building a nuclear power plant continue to be a barrier to new construction. Overall, the cost of nuclear energy is influenced by a variety of factors, including the size and location of the power plant, the cost of financing, and the regulatory environment. While the cost of nuclear energy can be high, proponents argue that the benefits of nuclear energy, including reliable, low-carbon electricity and energy security, justify the investment. The government can use subsidies and incentives to promote the development and use of nuclear energy. A subsidy is a financial assistance program in which the government provides financial assistance to the nuclear industry to reduce its costs or to lower the prices of nuclear power. For example, the government can provide tax credits or grants to companies that are investing in nuclear energy. These subsidies can help companies to offset some of the costs of building and operating nuclear power plants. Incentives, on the other hand, are rewards for nuclear companies that promote the use of nuclear energy. One example of an incentive is a feed-in tariff, which is a payment made to a nuclear power producer for the electricity it generates. The tariff is often set at a higher rate than the cost of electricity from other sources, such as coal or natural gas, to incentivize the use of nuclear energy. However, critics argue that these subsidies and incentives distort the market and favor nuclear energy over other forms of energy. They also argue that these programs can lead to the overproduction of electricity, which can lower the price of electricity and reduce the profitability of nuclear power plants. Nonetheless, many governments continue to offer subsidies and incentives to the nuclear industry to promote the development and use of nuclear energy, due to its potential as a reliable and low-carbon source of energy. The future of nuclear energy is complex and uncertain. On one hand, there is a growing need for clean energy to mitigate climate change, and nuclear power could play a significant role in reducing carbon emissions. On the other hand, there are numerous economic challenges that make it difficult for nuclear power to compete with other sources of energy, such as natural gas and renewables. One of the key factors that will determine the future of nuclear energy is cost. Nuclear power plants are expensive to build and operate, and the cost of nuclear energy has historically been higher than that of other sources of energy. However, there have been efforts to reduce the cost of nuclear energy through improved technology and streamlined regulatory processes. Another factor that will impact the future of nuclear energy is public perception. While nuclear energy has the potential to reduce carbon emissions and provide a reliable source of base load power, there are concerns about safety, waste management, and the potential for nuclear proliferation. Addressing these concerns will be critical to building public support for nuclear energy. Governments also play a significant role in the future of nuclear energy, as they provide subsidies and incentives to support the development of new nuclear power plants. In some cases, governments have taken steps to phase out nuclear power in favor of renewable energy sources. In terms of global trends, China is currently leading the way in nuclear power development, with plans to build dozens of new reactors over the next decade. Other countries, such as Russia and India, are also investing heavily in nuclear energy. Overall, the future of nuclear energy is likely to be shaped by a complex interplay of economic, technological, political, and social factors. While there are significant challenges to overcome, nuclear power could play an important role in the global transition to a low-carbon energy future. In conclusion, the economics of nuclear energy are complex, with both benefits and challenges associated with this form of energy production. While nuclear power has high upfront costs, it can provide cheap, reliable, and low-carbon electricity over the long term. If you're enjoying learning about the exciting world of engineering on our channel, be sure to hit that like button and subscribe to our channel. It really helps us out, and you won't want to miss any of our upcoming videos.